Hello everyone, very good evening, one and all. Welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S exam prep, and warm welcome to the session. Dear friends, in this Score Booster NIELIT 2023 series, we are practicing topic by topic from each subject. As a part of this, we have practiced from C programming, and in this week we are going ahead with the computer networks. We are done with physical layer and data link layer, and today we are going to discuss network layer concept. We are going to practice network layer concept. So please join the session quickly and mark your presence. Whoever have joined, kindly please confirm, am I visible and audible to you clearly or not? Am I visible and audible? Guys, this is the complete schedule of All India Open Mock Test for GATE 2024 aspirants, and it is live from 14th October till 20th October it would be live. So avail this opportunity, register and avail the benefit, dear friends. Okay. So this is the quick brief about me. If anyone are new for my classes, you can find my quick details here. So without any delay, here is the first question on your screen. An IP datagram of size 1000 bytes arrives at a router. The router has to forward this packet on a link whose MTU, maximum transmission unit, is 100 bytes. Assume that size of IP header is 20 bytes. If so, the number of fragments that the IP datagram will be divided into is dash. Whoever have joined, kindly share the session link to your friends so that they will also know about this session happening and they will also join. There is a router it has received 1000 bytes. It should forward this packet and it can forward max of 100 bytes, in which there is 20 bytes header. So only 80 bytes payload can be there. So number of fragments will be equal to, out of this 1000, you can keep maximum 80 in one fragment. So it would be 12.5, that means 13 fragments. Yes, correct. Dushyant, Satya, Shiv, yes, you are correct. Question number 2. Consider an IP packet with a length of 4500 bytes that includes 20 byte IPv4 header and 40 byte TCP header. The packet is forwarded to an IPv4 router that supports MTU of 600 bytes. Assume that length of IP header in all outgoing fragments for this packet is 20 bytes. Fragmentation value stored in third fragment is dash. Solve this question quickly and give your answer. It is given that an IP packet including 20 byte IPv4 header and 40 byte TCP header, right? Now, MTU of this is 600 bytes. Now, MTU includes header and payload. IP header length is 20 bytes means the payload must be divisible by 8. Okay. So, the payload can't be 880 bytes. Sorry, 580 bytes. 20 bytes of header is already there. So, the payload, it can't be 580. What is the nearest value less than 580? That is divisible by 8. 576. Okay. So, now the first fragment will have 576 bytes of payload and 20 bytes of header. Second fragment will have 576 bytes of payload and 20 bytes of header, and third fragment also will have, still there will be multiple fragments because the packet size is little big. Now, what would be the first fragment offset? Payload length is divisible by 8, the starting number, which is 0. So, 0 divided by 8, that is 0. So, offset of first fragment would be 0. And what would be the starting sequence number of second fragment? 576. So, 576 divided by 8, 72. And third fragment, (1000) 575 plus 575, that is 1152, I think. So 1152 divided by 8, 144. So the fragmentation offset value in the third fragment is 144. No, third fragment starting number, Gurumurti, from 5761151 is what? Second fragment's 576 bytes. Okay. Question number 3. Host A sends an IP datagram to host B. Both are on different networks. Assume that no error occurred during the transmission. When D reaches B, which of the following IP header field or fields may be different from that of original datagram D? TTL, fragment offset, checksum, source address. So options you have 1 only, 1 and 2 only, 1 and 3 only, 1, 2, 3. What would be your answer? Shiv has given the answer. I think by looking at this, I think Shiv, you have solved it in the gate, because this is a previous gate question. Yes, as they are on different networks, definitely TTL gets updated, and there is a possibility that offset may change when further fragmentation happens. When further fragmentation occurs, offset may change. When any field of header changes, header checksum changes. That means at every intermediate network, checksum is computed freshly. So these three will change, may change, but source address definitely will not change. So from the original datagram, these three may be different. Yep, correct. Question number 4. Organization has a class B network and wishes to form subnets for 64 departments. Subnet mask would be Yep. What's your answer for this question? It is given class B network. So we can say for network ID 16 bits, and as there are 64 departments, for subnet ID we can say minimum 6 bits. So 22 bits for net and subnet ID. In subnet mask, host bits should be zeros. Non-host bits should be ones. So 22 ones, remaining zeros out of 32. So this would be 255.255.252.0. So option D is the right answer. Yep. Very good, Dushyant Shiv. Keep it up. Question number 5. The last host address of network 196.140.110/27 is last host address, guys. Come on, give your answer, please. Yeah. See, when it is given /27, non-host bits are 27 bits. Host bits are 32 minus 27 LSB bits. So 196.140.130/24, and out of 110, (64, 32, 96, 16, 96, 8, 104, 108, 110. So this is what 110. Here 27 bits means take till here. So these are non-host bits, and these would be the host bits. Now, what would be the last host address? Last host address would means 196.140.130.011 Why? Why it is not all ones? Because all ones is a DBA or broadcast address. So this would be 196.140.130. It is 250, not 200, sorry, 126. So option C is the right answer. Last address will be DBA or broadcast address. That would be 196.140.130.127. but we were asked last host address. Okay. Yeah. Question number 6. An IP packet has arrived in which fragment offset value is 100. HLEN value is 10 and total length is 400. What is the number of last byte in packet? Options 459, 460, 1159, 1189. Yes, please. What's your answer for this question? We know that total length is header length and payload length together, right? We want payload length, that is total length minus header length. Total length is given 400 bytes. Header length we get by multiplying HLEN value with 4. So 400 minus 10 into 4, that is 360. Payload length is 360, but we want last byte sequence number. It is given offset is equal to 100. That means starting sequence number is 100 into 8, 800. So from 800, just count 360 bytes. So the ending number including 860 would be 1159. 1159. 800 is inclusive. Yeah. Yep, correct, Jay Shankar. Question number 7. The total number of hosts per subnet in the network with an IP address so and so is dash. Option A. Of course, see, number of hosts per subnet would be 2 raised to 32 minus n whole minus 2, because the first and last would be removed. So this is 2 raised to 32 minus 24 minus 2. 2 raised to 8 minus 2, 254. Correct, Aarti. Dushyant. Shubham, it's not A, it is D. Okay. Next question. Which of the following is not a private IP address? It's a direct question, dear friends, but there is a possibility to get question like this also in the NIELIT exam. C. Okay. Look at this. The private IP addresses range for class A, it is, if it starts with a 10, that is private IP address. So it is definitely private IP address. And 172 if it is starting and the second octet is from 16 to 31, then that is private IP address. So option C is not private. And in class C, when it starts with 192.168, then definitely it is private. So which is not private means option C is not private IP address. Correct, correct. Shubham? No. So this is the private IP address range for class A, B, C. Okay. Question number 9. Suppose a node with IP address 100.100.100.100 wants to send a packet to itself, self-delivery. Then the source and destination IP address fields would be dash and dash respectively. Yeah, correct, Samskar. Very good. So answer to the question number 9. See, the source address would be same, but the destination IP address would be loop back address. So the source would be 100.100.100.100, but destination would be 127.0.0.1. Option B, Aarti, not option C. Source would be same address, destination would be loop back address. Okay. Last question. The subnet ID of given IP address so and so is dash. in binary. Okay. From the given IP, we can say it is class B. So 172.148 represents network ID, and as per /20, excuse 20 bits represent non-host ID. So when 16 bits are representing net ID, for net ID, remaining 4 bits represent subnet ID. So in 172.148, that is representing net ID. In 152, the next 4 bits represent subnet ID, while the remaining 12 plus 4, 16 bits represent 8 plus 4, 12 bits represent host ID. So subnet ID value is 1001. Yes, because it is given in CIDR notation, Shubham, you can understand, right? Classless for subnetting. For network classification or for network ID, class restriction will be there always. Okay, so these are the top 10 questions of network layer, I can say, at NIELIT level. So the next class is the top 10 questions on transport and application layers. So these are the classes that we have already conducted. If you miss any class in the playlist, you will find the already conducted classes. So attend them, watch them and solve those questions. Okay. And these are my Insta and Telegram group links. If you have not joined yet, please do join, where I'll share PDFs. I have not shared any PDF yet. All PDFs together I'll share. Okay. Thank you. Thanks for joining today's class. Wish you all the very best. Hope you liked it. This session is useful for you in your NIELIT practice. If so, please do like, share and subscribe to our BYJU'S Exam Prep YouTube channel and enable the notifications. See you in the next session. Till then, have a great time. Take care. Good night, everyone. Jai Hind.